Right. So this is the differentiation. Okay, so have you put the heading differentiation? Yes, hopefully. Okay, here. So the first question is, what is differentiation? That's the first question, isn't it? Okay. What is differentiation? I have all got the link actually. Wait, let's see if I check. Okay. What is differentiation? Okay, simply in one word, if I want to say, differentiation is finding the gradient. Finding the gradient. Okay. Okay, so finding the gradient. Okay. So what is finding? Okay, what is gradient? What is gradient? Gradient is slope of the line. Okay, slope. Okay. So slope of the line. Okay, so what is slope? Oh my goodness. And we know that, for an example here, so this is a line. So what is the slope of the line? We know that from all levels and from the coordinate geometry. So the difference of the y over difference of the x. Okay, isn't it? So y1 minus y2 over x1 minus x2. Normally we say this is gradient. So slope of the line, gradient, which is gradient. Okay, so we call that as a gradient. Okay, so okay, that's fine. So then why we need the differentiation to find the gradients? So easily you can find no. There is a problem. If there is a straight line, for an example like this, y equals mx plus c. Quickly, I'll say quickly. I don't waste the time because you know already these things. Y equal mx plus c. So immediately we can say. Immediately, oh my goodness. Immediately we can say, oh, right. That's one. Okay. Immediately we can say this is m gradient. Is it clear? Is it clear? Okay. Immediately we can say this is gradient. So what is the slope of the line? So it can be any line. We can find the gradient. Okay. That is for straight line now. Now I'm asking. Okay. There is a curve. There is a curve. Say there is a curve. So the next curve, our familiar one is, other than the straight line, is y equal x square, quadratic. So y equal x square. Say y equal x square. Tell me, what is the gradient of this curve? So you can ask like that. What is the gradient? Mean how to ask? This is a curve. Okay, I'll ask clearly. Okay, so what is? Okay, if I find a point here, somewhere else, one point. If I draw the tangent to this point. Okay. If I draw the tangent to that point. Okay. If I draw the tangent to that point, then this tangent is line of. Then we can find the gradient of the tangent. No? Now one student asked me, okay, if there is a given point, says 2, 4, at that point to the curve, if you draw the tangent, so what is the slope of the tangent, or what is the gradient of the tangent? Will you able to find it? So for an example, he's asking at this point, what is the gradient of the tangent? At this point, what is the gradient? This point. Each and every point, if you draw the tangent, each and every point on the graph, if you draw the tangent to the graph, so you will be getting different values for that gradient. So first of all, how to get the gradient? What do you mean by gradient? So gradient is I'll tell you the angle, tan of the angle, tan of the angle, tan of the angle between the positive x-axis and the line. What is that? Tan of the angle between the positive x-axis in the line and the line. For an example, if I want to find the gradient of this red line, so I need to find this angle theta. So I have to take the tan. So tan theta is B. We know that. We are learning in BT graph also. No problem at all. So we know that is already tan theta is a gradient, right? So now the problem is I want to get the gradient at this point to this curve. Okay. Gradient of the tangent. So what is the procedure? How can I get it? So those days, it's a very big problem, right? So finding the gradient of the line is not a problem because we can easily, if we can find the equation of the line, we can find the gradient. But finding the gradient of the tangent to the curve, which is drawn to the given point, is a problem. Why? If I want to find the gradient of this line, then what I have to do, I have to measure this angle. Using the protractor, I have to measure the angle and I have to take the tan of that angle. Then I will be able to find the gradient. So think about each and every point. If you draw the tangent and measure the angle with the protractor and you take the tan value for that, is it possible? Is it possible? So then I have to make a log table like that. So I had to make a table like a log. So logarithm, you know, that each and every point they calculated, and we have the logarithm table. So they work out for that. So they spend the whole life sometime. So like that. If I want the gradient at this point, I have to measure this angle and find the tangent. If I want the gradient at this point, again I have to draw the tangent and measure the angle and I have to find the tangent. So which is very difficult. So in this situation, the man came who Mr. Newton. Mr. Newton. Okay. Mr. Newton introduced this calculus. Actually, there is another person also, but we say Mr. Newton. Okay. Introduce a calculus. Okay, guys, you don't need to measure the angle and find the tan of that. I will come up with the method. So he came with the method. So that is called differentiation. What's that? Differentiation. So what is the purpose of the differentiation? Finding the gradient. That's it. Finding the gradient to the gradient of the tangent to the curve at any point. Okay. So now, okay. So Newton came up with the one method. So what's that? So actually we have to prove that from the limits, but I omit that part because we will prove after mastering this differentiation. So Newton says, okay, not Newton, but he says, okay, so differentiation, what do you mean by the differentiation? Finding the gradient. So we gave, okay, if there is a curve y equal f of x, if there is a curve y equal f of x, we need to differentiate this. That means differentiation means finding the gradient of the tangent which is drawn to the curve. So think about that. At this point, tangent drawn. At this point, tangent drawn. At this point, tangent drawn. At this point, drawn. Like that. Each and every point, tangents, the values are differing, right? Each and every point. For when x equals 0, that's m. M means gradient of this at 0. Okay, we call that 0 because which is horizontal, right? When x equals 1 to this point, so m may be down, no, maybe. Say a1, I don't know. When x equals 2, m is a2. Likewise, itself it will form the equation, isn't it? So itself it will form the equation. So how to find that equation? That is the big question arises. So that will be found by differentiating. That means dy by dx. We introduced the notation dy by dx. So what do you mean by dy by dx? The notation has the meaning itself. What is that? Yx, that means dy means the d stands for the difference of y over difference of x. So this notation stands, it has the meaning itself because difference of the y over difference of the x means which is gradient, right? Dy by dt. So we put d because of the first letter of the word difference. So later we will learn not the difference. We call it as a derivative later. So derivative of y over derivative of x. Okay. So that is we call dy by dx, which means finding the gradient. Is it clear? So dy by dx is a notation what we are going to use to find the gradient of any curve. Is it clear? Okay, so there are no notes according to this. You can't write anything. So you have to understand. Okay, so you have to understand what is differentiation. What is differentiation is mainly finding the gradient, right? Okay, so why we put D? Because it's the first letter of the word difference. Actually, the first letter of the word derivative. Derivative of y over derivative of x. Okay, so these are additional things. So they won't ask why it came, why this came, and anything. So they will ask. Okay, so now I erase this point. Okay, still we have doubt, right? Okay, sir, we know that okay, different dy by dx is finding the gradient and everything. So how to do it? How to find it? For an example, one student asked me, sir, if y equal x square is there, okay, so without measuring the angle, without drawing the tangent to the curve and given point, and measuring the angle and taking the tan, so how you can measure this? How you can use your dy by dx? How you can do this? Then only I can. So then only I am going to say this, right? Differentiation is a process. Okay. Okay, that's a process. That means, oh, for an example, plus. What do you mean by plus? Plus means you have to add. Subtraction means you have to subtract. This means you have to multiply. This means you have to divide. So all these we have learned in our childhood. Okay. So, right. Finding the gradient means not average gradient. Finding the gradient is dy by dx. Okay. Right. So then likewise, there is a process we are going to learn how to differentiate. So what is that? How to differentiate. So the differentiation first rule says we have the proof, that is, but I'm not going to say the proof now. If x to the power n is there, if x to the power n is there, then if you differentiate this respect to x, what is the meaning of dy by dx? Finding the gradient, but in another meaning, both sides I am differentiating respect to x. Respect to x. That means n comes down and you have to subtract 1 and you have to put it. This is we call the first rule in the differentiation. So this seems to be the power rule in limits, right? This answer, yes, of course. Of course. Power rule in limits, right? Similar. But here, so we have the connection, but I'm not going to say connection because I know that without the connection, we can master the differentiation. After that, you can learn that. Okay, so dy by dx equals n into x to the power n minus. Okay, so dy by dx equals n into x to the power n minus 1. That means you have to put the number down and subtract the 1. So using this formula, you are able to find the derivative, the first derivative of x to the power n. Is it clear? So don't write now. So I'll tell you. Now I'm going to tell. Okay. Okay. So then what happens in this case? Okay. So what is the meaning of right? This is y equal x squared, right? We said there is a point 2, 4. Yes. You draw the tangent. Yes. We draw the tangent. And that this is angle theta. Yes. We found tan. Yes. What is that? That is m. Okay. So that is normal way. So using the differentiation process, how to do that? Then you need to know the equation of this curve. So y equal x squared. So according to that, y equal x squared. According to the rule, differentiation rule, what I have to write, dy by dx will be, put the 2 down and subtract the 1 from the 2. Then 2x. So it's 2x. So what is the meaning of this? What is the meaning of this? The meaning of this, when you put x equals 0, it will give the gradient at gradient of the tangent which is drawn to the curve at x equals 0. If you put x equal 1, it will give the gradient at the point x equals 1. Okay, so gradient of the tangent which is drawn to the curve at the point at x equals 1. If you put 2, according to that. So what is this? 2, x equals 2. So if I put x equals 2, there's a way to put x equals 2. So dy by dx when x equals 2. So that is m. That is m. That is 4. How? Because you substitute 2 here. That is the answer. See, those days they struggle a lot to find the gradient, to draw the tangent, to measure and find the tan of that. Right? So now after the calculus, what happened? You just differentiate and put the x value there. If it's x, then x value. If it's y, then y value. If both are there, both values. A point has x and y values, right? So if you put the straight away, you get the answer. So what is the meaning of dy by dx equals to that is 4? That means the y equals that curve, this curve, and the gradient, tangent drawn to this curve at the point x equals 2 has the gradient 4. Is it clear? Is it clear? Do you understand? Okay, so just differentiate, substitute, you get the answer. That's it. So now we have to write the notes. So I erase everything right now. So differentiation, under the differentiation, write down. Differentiation is the process. Differentiation is the process. Differentiation is the process to find the gradient. To find the gradient. To find the gradient. That's it. I don't need to say gradient to the of the tangent drawn to the curve like that, not like that. Finding the gradient, find the gradient, right? Is it clear? Okay. Well. Right. So that is the first thing. Second one, the first rule. First rule. Write down the first rule. Y equals x to the power n if. So dy by dx. You know everything about dy by dx. So I don't need to give the explanation for that. N minus 1. So you have to box it. So say n is real rational number. Okay. Real rational number. It can be minus. It can be a negative number. N can be a negative number. N can be a positive number. N can be a fraction, decimal. N can be any real number. Okay. So this is true. Just write down. And we'll start with the example. My favorite example always. We'll start with this 2022. So now find dy by dx. That means I am differentiating by respect to x. So it's better to write that here, somewhere else here. So write down dy by dx and say what is the meaning of this. Write down differentiating y respect to x. Differentiating y respect to x. That's it. Differentiating y respect to x. Differentiating y respect to x. Okay. Write down the example. Okay. Now exercise. Straight away exercise. Erase this. First rule. All of you copied. Okay. Let's see. All the students are there. Hope you didn't miss the class. Okay. Right. So what is derivative? Oh, I didn't write now. What is derivative? Example. Put 2022, the number down, and put X and write 2021. That's it. Is it clear? We will update one by one. No problem. Don't worry about it. So now exercise. We will master the exercise. Write down exercise. Exercise. Right. Okay. So question number 1. So y is given. So x to the power -5. So I can give 5 now because similar now. So it's minus. So I erase this. Okay. Hope you wrote it. Okay. Second one. Y equals x to the power 3x to the power 4. Second one. So you can find your own way to do this. Third one, y equals 5x to the power -4. Fourth one, y equals square root of x. Fifth one, y equals 4x cubed plus 2x squared. Sixth one, y equals x. Seventh one, y equals 2022 number. Eighth one, y equals 1 over x. Right. Quickly do it. There are 8 questions. I will give 2 minutes. Within 2 minutes, you have to finish. Okay. I'll do the first one. Differentiating both sides respect to x. So this is y, then dy by dx. Then bring the power down, -5. And subtract 1, -6. Because if you subtract 1 from -5, it's going to be -6. What about this? Dy by dx. bring the 4 down. 12. If you bring the 4 down, this is already you have 3. 3 into 4, 12. Okay. It will be multiplied. X cube, reduce 1. Okay. The next one, dy by dx. I put y prime because I don't have the space to write dy by dx. So I put y prime. So normally we say many students they say y dash. This is not dash. This is it's like a dash, but this is y prime. That is first derivative. What's the meaning of that? First derivative. Y prime. Y prime. Dy by dx. Instead of dy by dx, wherever you see y prime, so both are same. You have so minus 20, right? Because if you put this will be multiplied by minus 4, minus 20. Then subtract 1. So it's minus 5. Okay. Now this one. This one means x to the power half. So I have to, so I will write somewhere here. Before I go to the differentiation, I have to always make sure that I'm having the power, any kind of power. So this is square root, no? So I can put x to the power half. Okay. Now I can differentiate. I put y prime. So half down and x to the power. If you subtract 1, minus half will be there. So it's better to put in a red. Y equals half x to the power minus half. Okay. Careful. Square root means you can write x to the power half. Then bring the half and subtract the 1. So minus half. That's it. This one. Plus means we don't need to worry about this, like a limits. If it's plus, we can individually take from the same way. Y prime or dy by dx. I write dy by dx here. So I differentiate this 12x squared plus I differentiate this 4x. Here I differentiate this dy by dx. If you differentiate x respect to x, that is 1. Because you have 1 here, put the 1 and x to the power 1 minus 1, 0. So x to the power 0 is 1. So when we don't say is x to the power 0, we say 1. So if you differentiate x respect to x, that is 1. If you differentiate y respect to y, that is 1. If you differentiate t respect to t, that is 1. Constant. So y prime. Tell me. Anyone? Anyone? Give me answer. Third one I didn't put dy by dx. No, actually, okay. That is dy by dx. But there is another way of expressing the dy by dx is y prime, not y dash. Normally we say y dash, y dash. Y prime here. Y prime. Here, y prime. Y, I'll write like this. Now okay. Now okay. Y prime and dy by dx both are same. Seventh one, any answer? So type the answer. What is the answer for this? Y equals 2022. What is the answer? Let's see. What do you think? Whatever you think. What is the answer? 2021. 2022 again. Okay, let's check how many of you have answered. Let's check. Few are answered. Can't. Answer can't. So let's see what he has done. Let's check how many answers are there. What is the answer? Okay, so how many answers? 2022, 2022, 2021, 2022, 2022, 11 dy by d. Okay. There is so many inventors are here. This is, first of all, I would like to say this is not dy by d to 2022. No, that is wrong. Okay, right. So first of all, because we are differentiating both sides respect to x. That means, okay, I'll write it here. If I differentiate y, dy respect to x dx. That's it. Problem is there is no x. If there is a x only, then I can use the power rule. So I don't have x. What to do? But I can make x. How? 2022 into x to the power 0. Why? X to the power 0 is 1. 1. X to the power 0 is 1. So I can put 2022 into x to the power 0. Then if you bring this 0 into 2022, hereafter I don't need to write anything, because if you multiply by with the 0, everything becomes 0. Okay, I don't need to say. I will write again. If you bring the 0 into 2022 and x to the power minus 1. 0 into means what's that? Everything becomes 0. So answer is 0. I don't need to write this. I erase it, I just put 0. So for your explanation only, I wrote like this. But hereafter you need to understand very well. Wherever you see the constant into constant alone, wherever you see the constant alone, if you differentiate the constant respect to anything, that becomes 0. Wherever you see the constant alone, if you differentiate the constant respect to anything, that becomes 0. See one. Okay. Right? Why? Because this is x to the power 0. Bring the 0, 2022, x to the power minus 1. Why? Subtract 1. But we don't care about 0 into this. All becomes 0. 0 into that, all are 0. Okay. Why I say this? Why I say if you differentiate the constant alone, that becomes 0. Okay, why I said that? Because earlier I used to say if you differentiate the constant, that becomes 0. Earlier I used to say if you differentiate constant, that becomes 0. Then student came with something like this. Here, y equals 3x to the power 4. Okay, if I ask you to after saying this, then if I said to differentiate this, then they wrote that this is 0. I asked why. Then they said, sir, you said the constant, if you differentiate the constant, that is 0, no? So 3 is the constant, 0. Oh my goodness. Then I say, no. Not like that. If you differentiate the constant respect to anything that's 0, but constant must be alone. That means alone means it must be connected by the plus and minus only, not by the multiplication. Multiplication is that is not alone. 3 into. Okay, if it's 3 plus x to the power 4, then y prime is definitely this is 0. That is 4x cubed. Do you understand? If it's 3 plus x to the power 4, y prime will be 0 if you differentiate 3 0 because that is alone. Then after that only I updated to teach not to say constant if you differentiate the constant 0, but to say if you differentiate the constant alone. So the constant is alone. If you differentiate that, that becomes 0. Okay, right? Understood? Is it clear? So that means what do you mean by 3x to the power 4 means x to the power 4 plus x to the power 4 plus x to the power 4. So if you differentiate again 4x cube plus 4x cube plus 4x cube, 3 times 4x cube, 12x to the power cube, x to the power 3. That's it. Okay. So do you understand now? So then don't think about differentiating this is 0. No, this is multiplication. So 4 into 3, then you subtract. Now let's see. Can you again explain the sixth one? Okay, I'll explain that. So no problem. I'll take some time and explain. I know that you will be feeling after the street. We wasted the time just learning these things after learning many things. Okay. X to the power 1. If you differentiate that y prime, or you can put dy by dx, anything. This one, bring the 1 down and subtract 1. So that becomes 0. If you take the 1 from 1, that becomes 0. Now 1 into x to the power 0 is 1. That is 1. Understood? That's the sixth one. Okay. Can you explain the fifth one? Fifth one, individually you can differentiate. Okay, I'll put not the fifth one. I'm going to explain 8 and I'll put ninth one. Okay, then you will be able to understand. Okay, so eighth one I'm going to do it here. Here, eighth one. So y equals 1 over x. Then immediately you have to make it to the power minus. Now dy by dx. Bring the minus 1 down and subtract 1 minus 2. Later you can put minus 1 over x squared. Okay. Right. So I'll put question number 9. Question number 9. Let's see. Y equals 5x cubed minus 2x squared plus 3x plus 5. 10th one. Y equals 1 minus 2x squared plus root x plus x to the power 1 4. How nice, how nice. Only 2 questions. Just do it. Yes, same nice. Okay, let's see. So then synthetic division you taught earlier based on differentiation. No, that is not on differentiation. Okay, so that's a different. That's a synthetic. What is synthetic division is? It seems to be like that, but it's not. Okay, because we used only for x minus 1, x plus 1, that those things. So x minus 2 plus 2 if you use, that's going to be different. Synthetic division is different. This is differentiation. The differentiation rule is you have to be very clear. Whatever they put, you shouldn't forget the rule what I am saying right now. This is true for entire differentiation. Whatever they give, first you have to look at the power. Right? First you have to look at the power. So then you differentiate that by putting. After that, you have to see what is inside. So you will do that. First of all, you have to look at the power. Okay. I erase this. Dy by dx. Have anyone done this one first one? Correct or wrong? So have finished this. So that's a very another thing. Being able to finish that. Whether it's right or wrong. So apart from that, being able to finish that. So if you are not able to finish that means so there's apart from the right or wrong, so you have the high resistance. That means the complete, ignorance is there. If you can't finish it, it means there's something you can't take the decision to make it. Okay. Let's see slowly we'll do now. We first differentiate this, then this, and then this, then we don't care about the plus minus, right? Then if you differentiate this, 15 x squared. If you put 3 and subtract 1. If you differentiate this, oh my goodness, 3x squared, 2x squared. Minus 4, 2 into 2, 4, x to the power 1. Reduce 1. If you differentiate this 3x, that is 3. Right? So you need to know now, if you differentiate 5x, answer is 5. If you differentiate 6x, answer is 6. If you differentiate 2000x, answer is 2000. If you differentiate 8x, answer is 8. If you differentiate minus 4x, answer is minus 4. If you differentiate 3x, answer is 3. If you differentiate 5 alone, 0. I don't need to. Hands up or let me know those who got correct. Must be. Correct. Yes. Must be. Okay. So the next one, we move to the next one now. Before we move to the next one, I need to put this square root x as a half. First, I have to write that. So you will be wasting one step for that. I am not wasting because I erased that and I put it. Okay. X to the power half. Square root of x means x to the power half. Say y prime. Say O dy by dx, whatever it is. Okay. Y prime. So if you differentiate 1, 0. If you differentiate 1, 0. Then if you differentiate this, minus 6x squared. Okay. If you differentiate x to the power half plus half x to the power minus half, subtract 1. So if you differentiate x to the power 1/4, x to the power 1/4 minus 1 minus 3 by 4. That's it. Have you got it? Hopefully, this is the hardest one. Correct. Then 11. Let's say y equals 1 over x plus 1 over x squared plus 1 over x cubed plus 2 over x to the power 4. How nice this. Enjoy this. I erase 9th one because I need step for the previous question. So I put somewhere here 12. So y equals I erase this part, okay? Let's see. Y equals 3x cubed plus 2x squared over x. That's it. I put x squared. Nice, no? Any doubts? You can type. Where did the one go? That's the one. Which one? Which one? This one. 0. 0. If you differentiate one which is alone, that is 0. If you differentiate a constant which is alone, that is 0. If you differentiate a constant which is alone, that is 0. Alone means it which is connected by plus or plus or minus, right? Okay, so if you differentiate one respect to x, that is 0 because the constant, if you differentiate a constant which is alone, that is 0. Right. Okay, so I erase this one. Hopefully you all are done. 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 Okay. Let's see how things are moving. First of all, you have to make sure. So to write in the powers, y x to the power minus 1, x to the power minus 2, x to the power minus 3, 2 into x to the power minus 4. That's it. Now we have to differentiate this. Y prime or dy by dx, whatever, dy by dx. So if you differentiate this, put the minus and subtract 1. And put this minus 2 down, subtract 1. And put this minus 3 down, subtract 1. And put this minus 4 into 2, minus 8, subtract 1. That's it. Okay. That's it. If you have done like this, 100% correct. What about this one? I'm going to write one student's answer. Okay. The similar question answer. First, tell me whether it's correct or not. Okay. So one student, what he has done, so he said it is y bar, sorry, y not y bar, dy by dx, that is y dash. Okay. He differentiated like this. He says 9 x squared plus 4x over 2x. Correct? Correct? Yes or no? Yes or no? Yes or no? Yes or no? No. Yes or no? Yes or no? And student said like this. So the very lazy student, right? Just differentiation is the very easiest way. You differentiate wherever there, you differentiate, right? So it's wrong. Oh my goodness. Most of you, not most of you, all of you put wrong. No. The others didn't put, they may think, they may have another idea. Okay. So this is wrong, man. Don't do that like that. Okay. So don't differentiate on the top and bottom, right? Okay, don't do that. Don't differentiate that. Likewise. If the answer is 3, let's see. I'll come to that point. So how to do this? How to do this? Individually, you have to divide like this. 3x cube, or take x squared and you have to cancel over x squared, and 2x squared over x squared. How nice that. This is 3x. Oh my god. This is 2. Oh. So that is still y. Don't write y prime. So now I write y prime. Differentiation. 3x is 3. That is 2. 0. Answer is 3. Got it? If answer is correct, got it? Yes. Correct? Others? Done? So what is the main thing? So here, you know that what you have to do. So this one, here you have to divide individually. See? Individually divided. And here also individually divided. Then you see still you have y here. Right? Still you have y. So then after that, you have to differentiate. If you differentiate that, you will be getting only 3. This will be 0. So this will be 0. It's a constant stay alone. Okay. Okay. So let's see another. So it's a rule because the rule says only one rule we learned, that the rule is like this. The rule says wherever see y equals x to the power n, then you can write n into x to the power n minus 1. It's a differentiation. dy by d. So in this case, this is not this form, no? Okay, so then we have to make it to that form. Then individually divide only, you'll be getting this form. Understood? So the rule doesn't say you have to differentiate top and bottom. That's not that. Okay, so if you say sometime you may go to the power and you differentiate that, no, then that will be 0. No? Okay, so not like that. So we go for the question number 13. The good number 13. Right, question number 13. Let's see how we all are doing this. 5 minus 2x squared plus x to the power 1 over 5 over x to the power 1/3. Oh my goodness. Differentiate this. How nice. Same nice. 13. Then 14. You'll be having 14. Y equals 4 x plus 1 whole thing square. plus 3 by x to the power 5. Easy. Come on. Right. Right. Done. How many students? Let's see. 1, 2, 3. Okay, we'll do this. Y equals, individually you have to divide 5 over x to the power 1 third. X squared over x to the power 1 third. X to the power 1 third. 1 over 5 over x to the power 1 third. Again, still we haven't. So we have to simplify 5x to the power minus 1 third. Minus 2. 2 minus 1 third. 2 minus 5 by 3. X to the power 5 by 3. Then 1/5 minus 1 third minus 2 by 15. X to the power minus 2 by 15. So now simplify. So because we can only differentiate the power, that form, x to the power n form. So now we differentiate this, right? Prime. If you differentiate minus 5 by 3 x to the power, subtract 1. Subtract 1. Minus 4 by 3. If you differentiate this, minus 10 by 3 x to the power 2 by 3. Minus 1. Minus 2 by 15 x to the power minus 17 by 15. Right. So now if you differentiate this y prime, now the problem is we haven't updated our power rule. So there is another version going to come. After this, I am going to teach that. Another version what we have learned. So there's a new version is there. So then only you can differentiate this. Now you can't. So now you have to expand. So 4 into x squared plus 2x plus 1 plus 3 divided x to the power minus 1. I didn't differentiate still. I expanded, right? Now I multiply 4x squared 8x plus 4 plus 3x to the power minus 1. Now I have to differentiate. Y prime 8x plus 8, 0, minus 15x to the power minus 6. That's it. Is it clear? Now doubts? Okay. Is it clear? Is it clear? Is it clear? That is not stuck. I asked, is it clear? Right. Okay. Right. That's it. So, what's the next version? Did I tell about that one? Where I came across to this thing? What is the new version? I erased that one. So today is the introduction class, no? So it's going to be a bit heavy, actually. But I'll give some homework. Then we'll do. Before I homework, we know that x to the power n dy by dx is what we learned. This is a rule. Put the n and x to the power n minus 1. That means normally I didn't put the bracket. I just put x to the power n into x to the power n minus 1. That's that. That's all. Okay. Okay. So, right. So what's the problem is now the updated version I'm going to say. So what is the updated version is? Actual meaning is you differentiate this, you have to put the n down, subtract 1, and dot inside also you have to differentiate. That is 1. If you differentiate x, that is 1. That's why I put brackets. So you have to see the x inside also. That means, okay, so what's the meaning of that? So actual updated version is this. If y equal f of x to the power n, that means f of x can be anything, any functions, any expression, sin x, cos x, tan x, sin inverse x, sec inverse x, tan inverse x, 1 plus 1 over 1 plus x square, anything. So if you differentiate that, what do you get? Bring the n down. That's okay. Subtract the 1. That's okay. Copy whatever here. That is also okay. Then no problem, no. But you have to open another bracket and you have to differentiate inside and you have to put. That is f prime x. Or now I don't use the prime. I use df of x by dx. Why I am differentiating f of x respect to x. That means I have to differentiate f of x. If I want to differentiate y, dy by dx. If I want to differentiate t, dt by dx. If I want to differentiate z, dz by dx respect to x. If I want to differentiate f of x, df of x over dx. So this is the updated version. That means if you differentiate using the power rule, inside also you have to see and you have to differentiate. So there's that means it goes like that. Box, inside the box, there is a box. Inside the box, there is a box. Inside the box, there is a box. Then eventually you will find the 1. So it's a bit difficult to understand, but it's familiar. It will become familiar by doing 1 by 1. Okay, so now what we have to put is write down this. That's the rule number 2. Actually, it is the extended version of rule number 1. If y equal f of x to the power n, then write down dy by dx. Put the n, the power rule same as what we use. N minus dot, that means multiply f of x, differentiation of f from x. So I put f prime x. Here I can write what is f prime x. F prime x is df of x over dx. That means differentiating f of x respect to x. So this doesn't seem to be good for me until I make the examples. So we go to the example. So what the example says. So this is little example. Say x squared plus 1 whole thing to the power 5. Then if you want to differentiate this, okay. Normal way, if you want to differentiate that, what we have to do, you have to expand this up to the power 5 means you have to expand this x to the power 10 and like that it goes. Then individually you will find the power, then you can use this like this and you can differentiate. But after seeing this rule, I don't need to do like that. That rule says here the brackets anything. So the f y prime x dy by dx. First consider the 5 and 4. Whatever here, you have to write copying. Copying. We like copying. No, then we can do 100%. Don't worry, sir. Okay. So 5, you bring down and subtract 1, same as the power rule. But dot, you have to open another bracket, and in that bracket, you have to put the differentiation of this. That must be multiplied. So the differentiation of this, again, x squared is 2x plus 0. I didn't put. I'll go for the example 2 also. Then you will be able to understand very well. You have to copy this. You have to copy this. Example 2. So this is EG1. So EG2. Say y equals, say this time 3x to the power 5 minus 2x squared plus 3x plus 1 to the power, oh my goodness, the length, I stopped with this plus 1. Okay. To the power 2022, 22. See, you all are learning, no problems. Don't worry about that. Live classes are not starting or anything. So we have Zoom. We can learn anything, anytime, anywhere. Right. So we go for y prime. Sometimes, okay, this time I write dy by dx. Okay, so dy by dx. I state that dy by dx equals y prime. What I see is the power. I see the power. Then I bring it down. Then copy this here and make it 2021 dot. Open another bracket. So here you have to copy whatever here you have to copy. X to the power 5 to x squared plus 1. Right. And here you have to differentiate this, then you have to put. That means this. See the original, okay? Original means the question. Don't see this and because sometimes you may differentiate this and multiply. Then that and multiply. No, not like that. One time you have to do, one time you have to open another bracket. That's it. So if you differentiate this 15x to the power 4 minus 4x, if you differentiate this minus 4x, then 0. That's it. Is it clear, guys? Is it clear? Do you understand? Okay, so we start from, we stopped 11th question, right? Or 10th question. Let me know. The question we stopped there. 13, 14. Then we had to start 15, isn't it? Next 15, right? Copy this and write down 15 under that. I'll give some time, then only you will be having, otherwise if this becomes secret, you may get, okay, it's okay. We will stop like that. No. We will finish this, then homework stop. Okay, so if I can have 3 hours class, then no problem. So until then we can finish. Until then means up to some 30. So normally I used to do 50 questions. Right. So shall I erase this? So you can put the box. So I have to put box for this also. Because I didn't put D F of X over D. If I put that one, I put there. So I erase that. Rule is very important. Keep the rule in your mind. Yes, I am going to erase. Yes. Erased. So 15, write down 15. Let's see, now you all are okay. Y equals x plus 1 to the power 2022. 16. Y equals 2x squared x plus 1 cube. Okay. 17. Y equals square root of x plus 3 into x to the power 1/4. All things square. Oh my goodness. 18. 18. Y equals 1 minus 2x squared plus 1 over x, all thing cube. Enough, no? So we will do this. I put here 19. Y equals root x plus 1 over root x, whole thing cube. 20. Y equals square root of 1 minus 3x cube plus root x. 21. Y equals 1 over square root of 5 minus 2x cube plus x to the power 4. 22. Root of x plus 1 plus 1 over root of x plus 2 plus 1 over x. These are homework. And here I will do only 15th question. So y prime that equals, bring the 2022 down and put the bracket and write down 2021 dot. If you differentiate inside, that is 1. So sometimes we don't put if it's 1. Okay. Then here y prime. So if you bring this is 6. X squared plus x plus 1 to the power 2 dot, open another bracket and differentiate and put it here. 2x, differentiate this one, okay? Not this one. Inside the box, inside the bracket. 2x plus 1. Okay, I'll give some time here after. Good. hopefully this is going to be guys. Squared, no? Y prime, bring the 2 and to the power 1. Then copy this. Copying is our dot. Open the brackets. This 3 is there, then I put here. I differentiate this x to the power half. Think about x to the power half. Half x to the power minus half. Dot. Not dot plus. This one 3 by 4, 1/4 no. X to the power. Tell me, subtract 1. Minus 3 by 4. Minus 3 by 4. So here if you differentiate this, y prime, put the 3 and put 2 and copy it. So 1 over x. 1 over x means x to the power minus 1. Open the bracket. Open the bracket and differentiate 1, that is 0. Then minus 4x. Minus 4x plus x to the power minus 1 minus x to the power minus 2. That's it. Okay. Very good. So I'm going to conclude the class right now because this is the introduction class. I don't want to continue hereafter because you have to go through again and you have to become very strong in differentiation. So don't worry about the differentiation. 150 marks I will bring to you, right? So believe me, this is that much of easiest thing. Okay, 150 marks in pure mathematics. If you can do quadratic equation and remainder theorem 150, 300, then we are moving. So trigonometry, you can get 150, 450. Now only you are pass 450. So if you can do first part, trigonometry 1 question, 25 marks. And differentiation, then you will be able to do that 1 marks 50, so 500 marks, half marks gone. Right. Another 250 if you can get it, then sure A is the result. But you have to work hard. So don't think here and there, and don't, okay, just if you believe, okay, this is correct, okay, we are going in the right way, then okay, no problem. So you need to know what is happening around you also. Right? So, okay, guys, these are the homework. Please copy those homeworks. Answer those who have copied. So today I'm going to conclude the class right now. So next differentiation class will be approximately 2 hours, right? So get ready for that one. So next class, I'm going to put the differentiation class on coming Wednesday, not the Friday, okay? Coming Wednesday differentiation, okay? Not the Friday, okay? Because it's a new chapter now, we don't need to give the big gap, okay? So as soon as possible, we can do 2 classes consecutively, then easy always. After that, we can put later. So the next week, what I am going to do, I'm going to switch that. PT graph goes to the Friday class and differentiation we continue, right? Is it clear? Okay, if possible, that revision class also, we can make it as a 1 theory class. Let's see. Okay. Okay, guys. See you.